Welcome to Community Conversations, our session for December, the last session of the year. I'm Taryn Blake, Community Engagement Program Manager, and I'll be your host for this enablement session, brought to you by Siemens Digital Industries Software. So as you can see, our topic for today is creating a lift turn station. Our usual host is Stefan Bongso, and he is a freelance simulation expert and has been for quite some time now. So yeah, he has 5 books on plant simulation, and he's definitely working on a 6th book. And he is one of our leading contributors to the Siemens PLM community and a community catalyst for us here. So for today, these are the big steps, right? So he'll go through creation of the graphics, animatable objects, joints and poses, a basic scenario, and then programming the movements. So as stated, we'll have the Q&A afterwards, and that's all I have for our introduction. Stefan, feel free to steal the screen.
Hello again to our next session. This is one basic session for dealing with 3D. I guess you know, next year Plant Simulation will stop the support for 2D, so all the models you will create with the new version of Plant Simulation must be 3D. And I guess many of you already know it's a complete new world if you are making your simulation in 2D. Then you have your icon editor and make there your icons, and maybe you make it colored different way. But in 3D you have much more possibilities. And so my example for today is you have to simulate a lateral transport, and the part must be rotated by 180 degrees. Somewhere in between or during the lateral transport, there are a lot of different ways to do this. And there are also a lot of different ways technically you can do this. One way, for instance, would be you have a cross-sliding car, and the cross-sliding car lays down the part on a turning device, and then it will be turned and then lift again, and then transport to the destination. Another way would be that the cross-sliding car is transport apart and turns during the transport. Another way would be you have a chain conveyor, and the chain conveyor stops on a certain position, that the part will lift it and then turn by 180 degrees and placed again on the chain, and then the chain conveyor will track the part further to the destination. So we have really a lot of different ways, technical, how this could be solved. And in our simulation, we have 2 different ways. One way would be we use the conveyor to simulate this, or we use a point-oriented object like the station. And in this webinar, I want to take the station to simulate this lateral transport and the rotation by 180 degrees. The station as a point-oriented object has one big advance. We can change the conveying direction. If you, for instance, need to change the conveying direction to simulate backwards transporting just by rotate the icon, then you can only do this on a point-oriented object. You cannot do this on a conveyor. If you want to do this with the conveyor, then you have 2 commands. One command is play rotation, and the second command is play translation. And with these 2 commands, you also can do this task in your simulation. But here in this example, I want to use the station to show some really basic concepts in 3D modeling. Okay, first I create one really simple example. I have one source. I have a conveyor. Interesting. I have a second conveyor in the other direction, and I have a train. Next, I change the part 1 here from user objects, part A. I want to change the size of this part. It should be 5 meters long and 1 meter width here. And my source should produce this part, this long part. And this part I want to turn. Okay, I need to write cheating object. Oh. Okay, and now I need to develop a lateral transport from here, from conveyor to conveyor 2, and I need to turn the part by 180 degrees. Okay, first I duplicate the station and name it and rename this as cross sliding car. Lift, rotate. And first I want to change here the icon of this cross sliding car. I make it here in the class library. So I need to go here, right mouse click, and then open in 3D. I delete all this stuff. And it should be only, I need to create a cuboid, should be 5 meters long, 1 meters in y direction is okay, and 0.1 as dimension set. Okay, well, I can make another color. I activate the material and make it red. Okay, I have forgot one here, and then I need to place the underlight. Okay, this is now my cross sliding car, and I want to be able to move this cross sliding car in. Wait. Okay, I want to move this cross sliding car in Y direction, then in Z direction, and I want to be able to rotate this this cross sliding car here. And to be able to do this, I need to add some animatable objects into this graphic here. And you can do this, right mouse click, and then show graphic structure. By default, you have here a graphic group default, and here's my graphic. I need to change the position of this later. You can go top to, yeah, and then right mouse click, and then add animatable object. You need to give a name here, and the first should be lateral. And you see it's so a small symbol like robot arm. You have this is the symbol of animatable object. Next, I need one joint in Z direction, and so I need another animatable object here, and starting from lateral, right mouse click, and then add graphic group. This should be vertical. Okay. Okay, this wasn't right here. This is only a graphic group. I need an animatable object. And vertical should look like this here. Also, this graphic group has a default a graphic group default here. And from this vertical, I need one animatable object for rotation. And so I create a third graphic group or a third animatable object for rotation. This structure is very important to be able to follow the rotation while it's moving lateral. It needs to be a structure inside of lateral. All these animatable objects needs to be inside of lateral. Lateral is our top, and then I need to cut here this my graphic from the basic default graphic group and copy it down into the animatable object for rotation. If you have a robot in plant simulation and the robot is able to move like it should move, then you will find also such a structure with 4 or 6 animatable objects, one inside of the other. If you have only a flat structure, then it doesn't work. Okay, now we need to adjust the joints of each animatable object. The first one should move in Y direction, and so you can go on this animatable object and edit 3D properties. You will find one tab joint, and here we need to define first what kind of joint should this be here. This should be a prismatic joint. Another for rotation, we need a revolute joint. Prismatic joint moving in one direction. And we need to set here a translation direction. And the first translation direction is along the Y axis. We need to set here a speed. And also here we can set limits for this joint, but we need to set a speed, and I want to have a velocity of 0.5 meter, 0.4 meters. You can activate also acceleration, deceleration if you want, but it's enough for now to have speed here. Okay, then our next animatable object is vertical. So you open the 3D properties for vertical, and it's the same. We need to go to joint, Then we need to set the right axis. It's now set. And we need a speed for velocity, maybe 0.2 meter per second. And the third one is rotation. Added 3D properties, joint. Now we need a revolute joint. And for revolute joint, we need to set a rotation axis. The axis set is okay. You can set a rotation center outside of the center of the object if you want to do this. And we need to set a velocity in grade per second. And I want to turn within 9 seconds 90 degrees, or within 15 seconds 80 seconds 180 degrees. And so I need to set 10 degrees per second as a speed, and you can also set the acceleration if you want to. Okay, now we have set all the axes of my object. And now we go into the model. And we can see, okay, this is now my object. I need to change the set position to 1, that it's on the same height as the other objects. And then we need some SimTalk programming. First, I need some state of this cross-sliding car. And I want to have this as a user-defined attribute. So I add in the class library a user-defined attribute. Is ready as Boolean, and the initial value should be true. So next, I connect this with connectors here. And it should be 8 meters away. Maybe we need to track it a little bit later. Okay, and I need an exit control in this conveyor. Quite easy, just need to wait until my cross-sliding car lift rotate is ready. Then I set this to false. And then I move the part onto this cross-sliding car. Here, it's a point-oriented object, so it doesn't, moves the complete part onto this cross-sliding car and doesn't consider that it takes some time to transport the part from the start to the end of this object. And this we can set here as processing time for this cross-sliding car, maybe 15 seconds. And then we can start the movement of this cross-sliding car in the exit control. So I want to make here exit control. So now we have basically 2 ways to do this. One way, we can edit here in 3D properties. We can set up poses. Yet a new poser for maybe test, and then we can move these 3 joints maybe first lateral until 4 meters, then only vertical to minus 0.5 and so on. We can define here a lot of poses. But we can also move these joints directly, and this I want to make here in this example. And so I create here an exit control. And the first step, I want to move this object lateral 4 meters. And we need to write here this in this way. Question mark is my cross sliding car here, point, underline 3D. All 3D stuff starts with underline 3D. Get object. We need to address the object I want to move, and then move to lateral. Yes. This is the first step. And this we can test. I just comment here at move. We move at the end the part to the successor. But in the first step, I just want to check if it's moving in the right direction. So it doesn't. First, I need to check the controls, accent controls, okay. So once again, it doesn't move, it doesn't show the movement on the here. We don't see it here. And the reason is we need to adjust the MU animation if we make some changes in the graphic structure. Open the cross sliding car in 3D window, and then mark the graphic. And if you see its lateral vertical rotation, it's already the right object. Right, open it in a new 3D window, and here we need to add MU animation. Edit 3D properties, and here there's no MU animation by default. We need to add one. Type lines is okay, and the path name needs to be for the station default. Okay. Then you can show this, and you'll see here anchor point, and you can change the position of the anchor point if this is not the right position. This is step 1. You need at the end, at the last object in your graph, in your graphic structure, you need to add one MU animation. So now I go back. Edit 3D properties. You see it's user objects, lift, rotate. I'm in the object again. And now I need to change the animation object. Animation object's not here in this object. It's now in lateral. Point. Vertical. Point. Rotation. You need to address the right object where you have entered the MU animation. And only then you see the movement on the part, on this object. Here, let's have a look. It should not move the part to the successor. Okay, I don't have saved the changes here. And so the move command is still active, and if you have done it right, then it should move to 4 meters. And then it stops. Okay. So now I want to lay down this object, and then it should rotate by 180 degrees. Then I want to lift it again, and then the movement should go to 8 meters, and then I move the part to the successor. And so we need to extend the exit control here. So this move to command returns the time it needs to create this movement. And we can set here a wait. So this program waits until the movement is done. You can also move several axes in parallel. Then you don't need to wait. Maybe you need to wait for the longest time one movement needs. I set some weights in between, make it more realistic and from the movement. Then I want to move 0 meters down. And it starts in the same way like here. But so we only address lateral, and then from lateral we can address the next one. It's vertical. Move to and minus 0.5. And the same with rotation. I wait 1 second. And then I started the rotation, and it's the same approach here. I need to address rotation, and rotation is get object lateral, get object vertical, and then get object rotation. Move to 180 degrees. And this I want to check. Okay, and now I need to lift and move lateral additional 4 meters. And so this is only copy and paste. I wait 1 second. The vertical movement I have already here. I move back to 0. And I move lateral to 8 meters. Then finally, I move the parts to the successor. I wait 5 seconds until the part is has left my object here. Move to 8 should be here. And then I want move back with double speed. And for this purpose, you can set a second parameters in move to, and you can force the movement to be finished after a certain amount of seconds. After 10 seconds, this should be finished. And one important stuff here is we can only move, this is to 180, and then we need to move back. If we move from starting from 180 to 180, it doesn't move. And so I need to turn this this cross-sliding car back, and it's for me just virtual. And I need this command here, but I move to 0 within 0 seconds. Otherwise, we cannot move again to 180. After the first rotation, we are on position 180, and we need to go back if we want to rotate again. And then I wait 1 second again, and then set is ready to true. This is basically how to address all the animatable objects. It's a hierarchy here. It starts with lateral. Below lateral is vertical as one animatable objects. Within vertical is a rotation, and you can place a lot of different animation objects here, animatable objects here into one object, and so you need to address the right one. And then you can address directly the joint to move for a certain amount of degrees or meters. Okay, let's have a look. Okay, remember we have this first time for transport the part to the end of the cross-sliding car and start all the movements we have here in the processing time. We can change this maybe to 5 seconds to let it run more smoothly here. Okay. All these movements take a lot of time, and you may change this behavior. You can try to turn this part during the lateral transport of the part. And this we can do with the same object now. We only need another exit control. So you can do these movements in parallel. I delete my exit control from here and create a new one. Now I want to move lateral and rotation at the same time within 20 seconds. And here I start again with underline 3D, point get object, lateral, point move to, eight in 20 seconds. And at the same time, I want to move rotation to 180 degrees in the same amount of time. And so I can make here this construction weight. I don't need max here. Okay. I make it complete. If there are different lengths of these movements, you can set, you can use max to calculate the maximum time that you need to wait to finish both of these movements. And then I only need to set these two movements here after each other here in this max command. And now it will be very long. Okay, it starts with lateral, point, get object, vertical, point, move, and get object. Point, move to 180, maybe within 80 seconds. Here I missed something. Okay, this is for max. At the end, 7. Yes. It's all inside max, and the maximum time should be 20 here, and here it's 80. This should wait 20 seconds then. So the lateral movement is finished. Also the rotation movement is finished. Then wait 1, and at move, then it goes out. We wait 5 seconds and move back. We have already this here. Move to 0 in 10 seconds. Then we need to rotate back. Move to 0 in 0 seconds. And then wait 1. And VSET is ready. To show. So you have an example for two movements in parallel. This would be one possible way to do this. If you don't wait, you can start several movements in parallel. And in our example now, it should move to the cross-sliding car and then start moving and turning at the same time. Okay, now it should come back. Doesn't come back. Maybe I've moved to material, moved to 0. I need to save. Yeah, it doesn't save my changes in the editor. And now we have the movement in parallel. It saves a lot of time, but you need complete different equipment if you want to do this. And in the same way, you can calculate, you can model a technical solution where the cross-sliding car stops, and from down it comes a device to lift up the part and then turn the part and then take it back from a chain conveyor where a lift device is there, lift it up, take it down to the chain after turning it, and so on. Okay. That's my webinar for today. We have questions.
And I see one just popped into the comments. Are you able to see it, Stefan? He's asking, can you please show the graphic structure tree of the lift to show the animatable objects?
I open the lift, and then you go in the background of this, and then right mouse click, show graphic structure, and this is the graphic structure of this object. Lateral, inside of lateral, vertical, and then rotation. And this is the icon for animatable objects, this robot arm here. And these are graphic groups, this with the square. And graphics are here with the cuboid at the start. This is graphics.
Hi sir, this is Umesh. I have a doubt regarding animation only. It's like regarding pick and place. So,
Okay.
like I have a JT file of a robot. In that, if I give joints, it will work like how I giving the joints, or is it needs to be replaced with only existing pick and place?
For pick and place, it's quite the same. You need this like of structure. If you get, for instance, a JT from a producer, then this structure is flat. It's all on the same level here. And if you go to the pick and place robot here, I open it in 3D and see the graphic structure. It looks quite the same here. You have here the graphic structure as a hierarchy here. And
okay. If I give joints, automatically it will get it, right?
A plan simulation only supports only a few configurations. You need to have the same axis here in your robot. Z, Y, Y, Z, Y, Z. And if this is not the right, if it's not this this configuration, Blend Simulation will not be able to use your robot as a pick and place robot. It will not work. Yeah.
In that case, we have to replace with pick and place after giving the joints.
Yes, you can. For instance, here I have Blend Simulation has some pick and place from KUKA. I can.
Yeah, it will work.
It's because this has this graphic structure, the same like the pick and place robot has by default. The axes are Z, Y, Y, Z, Y, Z, and so you need to create your robot. And there's a webinar. There's a video in the default video connection. I guess it's 25, and this video shows how to create this robot configuration from a flat structure.
Okay, sir. Got it. Thank you, sir.
You should be seeing on your screen right now. This is someone asked about where is the recording and when can we get it. It will be available on Friday. You can click the link in the chat or the link on your screen for the Plant Simulation user group. So it will take you to the webpage that looks like what you see on the screen. The animation is just showing you that we recommend that you click to follow this topic, which will subscribe you to it, and then also click the envelope icon to select every post. So the only thing that is posted in that area are recordings for these sessions and registration links for the sessions, and then there might be an occasional topic around or a question around what topics you'd like to see. So the forums are there, and then our next session will be next year on Wednesday, January 14th. So I've posted the link there. You can click on it if you know that the topic, Job Shop Basics, looking at push controls for those. If that is of interest to you, you can click through right now and get registered. So you'll get reminders in January. But that is the only thing on that. And then our team at Accelerator Academy always likes me to remind everybody that there are like courses, on-demand courses that you can follow for the topics on the screen. You can click on where it says Technomatics Plant Simulation or the Plant Simulation Associate Certificate if you want to go to the web pages for Siemens Accelerator Academy. So those will be good. And then I'm just popping up Stefan's contact info for the community profile. You can click there to get to his profile. So.
Thank you all. And yes, we continue next year. Have a nice holiday and Happy New Year. And hopefully we see us next year.
Yeah. Thanks again, Stefan, for a great session. And we'll see everyone in the forums.
Thank you, sir. Thank you, ma'am.
Bye.
Bye.